Getting ready for a machine learning interview? Well, you're in the right place. We're about to run through some of the most common questions you're likely to face.
We're going to break this down into 4 key areas. First, the core concepts you just have to know. Then we'll get into data and model building, touch on some popular algorithms, and finally, we'll talk about how to know if your model is actually any good.
All right, let's kick things off with Section 1, ML Core Concepts. Getting these right is absolutely crucial.
Here's a question you can basically guarantee you'll be asked. What is the difference between supervised and unsupervised machine learning?
It really all comes down to the data. Supervised learning is kind of like learning with a teacher. The model gets trained on labeled data that already has the answers, so it can learn to make predictions. Unsupervised learning, on the other hand, is like learning all on your own. It gets unlabeled data and has to find all the hidden patterns and structures by itself with no guidance at all.
Now, let's talk about a super common pitfall when you're training a model. What is overfitting? And more importantly, how can you avoid it?
Simply put, overfitting is when your model gets a little too good at learning the training data. It doesn't just learn the patterns, it starts memorizing the noise too. And what happens? Well, when it sees new, real-world data, it completely falls apart because it can't generalize.
So, how do you fight it? Well, here are 3 really powerful ways. You can use regularization, which adds a penalty to stop the model from getting too complex. Or you can just make your model simpler, with fewer features. Another great tool is cross-validation, where you train and test your model on different slices of the data to make sure it performs well consistently.
This next concept is a classic trade-off you need to understand. What are bias and variance in a machine learning model?
Think of it like an archer aiming at a target. High bias is like an archer who consistently misses the bullseye in the exact same spot. The model's assumptions are just too simple, and it's systematically wrong. That's called underfitting. Now, high variance is like an archer whose shots are scattered all over the place. The model is too complex and sensitive to the training data, so its predictions are inconsistent. That's overfitting. The goal, of course, is to find that perfect balance. Low bias and low variance, hitting that bullseye every time.
Okay, time to get our hands a little dirty in Section 2. Data and model building. This is where the theory starts to become reality.
And here's a fundamental question for this section. What is a training set and a test set in a machine learning model?
It's a really simple but totally critical split. The training set is the big chunk of data, usually about 70% or so, that you use to actually teach the model. The test set is the smaller portion that you keep locked away. This unseen data acts like the final exam, giving you an unbiased report card on how well your model will actually perform in the real world.
So, what's the big picture here? What are the 3 key stages of building a model in machine learning?
It's a pretty clear, logical flow. First, you have model building. You pick an algorithm and you train it. Second, you do your model testing. You use your test data to check its accuracy. And finally, once you're confident it's working well, you move to applying the model, where you use it for real-time projects.
Okay, so you know the process of building a model, but which algorithm do you actually choose? That takes us to Section 3, where we'll look at a couple of popular and really powerful options.
First up in our algorithm showcase, what is a random forest?
The idea here is basically the wisdom of the crowd. A random forest doesn't just rely on one single decision tree. No, it builds an entire forest of them. Each tree gets a slightly different look at the data and makes its own prediction. The final answer is then just a majority vote from all the trees in the forest. This makes the overall prediction much more accurate and stable.
All right, let's switch gears to a different type of algorithm. Explain k-nearest neighbors, or KNN.
KNN is beautiful because it's so simple. You are what your neighbors are. To classify a new data point, the algorithm just looks at the k data points that are closest to it. You get to choose the number for k. If k is 5, it looks at the 5 nearest neighbors. The new point is then assigned to whatever class is most common among those neighbors. It's just classification by proximity.
So, you've built a model. How do you actually know if it's any good? That brings us to our final section, evaluating model performance.
A key tool for this is the confusion matrix. So, how would you explain it in a machine learning context?
A confusion matrix is basically your model's diagnostic tool. It's called a confusion matrix because it shows you exactly where your model is getting confused. It compares the actual truth to your model's predictions, so you can see not just if it's wrong, but how it's wrong. This table tells you everything.
And diving a little deeper into that matrix, you'll often be asked to define two very specific metrics: precision and recall.
Okay, so precision answers the question, of all the times we predicted something was positive, how many times were we actually correct? It's the ratio of true positives to all predicted positives. Recall answers a different question. Of all the things that were actually positive, how many did our model successfully find? That's the ratio of true positives to all actual positives.
And that's a wrap on some of the key questions. If you found this breakdown helpful for your interview prep, go ahead and like the video and subscribe for more.